Hi, welcome to my tutorial about AI. There are many parts of AI. I've worked as a prompt engineer, so I'm going to talk about that. There are also there are also many specializations of prompt engineering. My specialization was full stack or programming. So what is AI? We've It's been hyped up recently, but in the simple form, AI is just any computer program that mimics human behavior. So we've already had a lot of AI in the past, but recently it's gotten more powerful. So the difference between AI and normal programming is that with the new AI, it's using multi-thread, it's using the GPU. So compared to the previous programming style was more sequential. When you're using GPUs, it's more often a multi-threaded processing design. And the reason to use the GPU is because, let's say on your computer, your CPU has 12 cores. Well, your GPU has 1,000 cores, so that's like 100 times multiplier just by using the AI software. And if you're wondering what tensors are, tensors and GPU are used somewhat interchangeably, but GPU is like you can use the GPU to train the AI, but tensors are more like hardware specifically designed for AI training. It's more powerful than GPUs. And another difference between AI and traditional programming is that AI it's more centralized. You can have um, test data or input samples that are thousands, millions, or more, and you have the GPU processing, and you could have like thousands, millions of tensors running. So all this concentration of resources means that it's probably on the cloud because only the cloud can centralize that much resource in one place. So there are many different approaches to how AI is processes data. The most simple one would be something like a dictionary lookup. So, for example, you go on the AI and you ask, "How do I print a hello world?" Now, you don't. The AI doesn't have to like use algorithms to generate that for you. They can just look. The AI has prompt engineers who provide it with data such as how to print out a hello world. The AI does not have to. The AI merely has to look up a database record and then copy and paste the response back to you. So not a lot of algorithms needed in that case. So that's number two. Number one is manually programmed algorithms. So I guess this when you're programming in GPU and you got thousands of tensors running or millions, this kind of algorithm is a lot more complicated than your traditional sequential programming. And number three, it's usually a mix of number one and number twos. Um, oh, so the algorithm it uses brute force to modify some of its parameters. Like there is a baseline algorithm, but you can modify a few parameters and adjust it to see the best fit. So you could try out like maybe millions of combinations and compare it against the training data. The training data is usually what the correct output ought to be. So eventually, one of those parameter configurations matches the best to the training data, and that parameter combination is selected, and then it's built further on based on. I think you call that a I think you call that a stage, and so you then make some modifications to the previous stage, and then you repeat the process. And number four, you have a mix of one, two, and three. So AI, it's not a single program. It's multiple. Sometimes it's multiple programs put together. So the prompt engineer is the person that provides training data for the AI to learn from. So typically, the work consists of prompt and response. The prompt will be well, the AI companies, they prefer to use real case samples, so they don't just like make up a prompt. They check out what people are commonly searching for, and they decide, okay, this prompt is being commonly searched, and we're gonna get a prompt engineer to give a response to this. And one of the advantages of using an AI is that let's just say you didn't have an AI. If you didn't have, if you wanted to call a programming tool, you normally have to first learn that programming language in order to use the tool. But with an AI, you can, the AI can understand what you're like. It can understand English, so it can convert your intentions into code, and that makes things a lot simpler. The AI has many development stages. Of course, it doesn't get, it's not perfect on the first day. So the early stage AI, it used publicly available data from the internet. So basically, it was just web scraping. And you might think that the internet has a lot of stuff, but um, it's that's not always the case, which is why you need prompt engineers to provide it to verify a lot of the data and to provide higher quality, more condensed thoughts. And thirdly, once the prompt engineer has trained it AI with enough data, the AI is able um, to somewhat think on its own, and at that point, the prompt engineer then helps edit the AI rather than training it entirely from scratch. And lastly, if an AI is really good, then the prompt engineer is just tasked with trying to break the AI, trying to make it have a mistake. So I have a whole slide on why what web scraping doesn't work. So first of all, you might think that the web has a lot of content, but there are a lot of cases where there are no search results for a query, and and you might think that there is actually an answer, and people claim they have the answers, but they don't. So you have to verify all that. And so when you look up some of these samples, for example, if you were to go to GitHub, then when you download the GitHub code and try to run it, you find out that the project doesn't even run, or it does run, but then it doesn't run properly because I guess whoever pushed that GitHub code, they didn't verify their stuff before they pushed it on the web. I mean, this the web is you can just basically write whatever you want on the web, so not everyone verifies the stuff they're publishing. And let's assume that um, that the GitHub sample runs and it runs properly. There's also the problem that they didn't make it efficient. So a lot of times their code is overcomplicated. It has unnecessary features. It's not modular, and usually it's only designed for narrowly designed for a specific use case. You can't really copy and paste the code to do other stuff, which as a prompt engineer, if you're trying to learn from the samples on the internet, and you probably need to make some adjustments. So the fact that the code is designed for a specific use case. It is not very portable code. And lastly, if everything is fine about the GitHub samples, there is still the issue that the code is not broken into independent segments, which means that the AI, if you were to copy and paste the project, the AI would not be able to figure out how the sequence works. You gotta like break it down into small chunks that are easy to digest for the AI to understand. And also, the AI, it needs explanations along with code. The explanations do help the AI learn and understand. AI is able to understand English explanations, and also sometimes when you go and search on the internet, you read explanations, and those explanations are wrong. So you gotta again verify everything. The prompt and responses are typically divided into two types: single turn and multi turn. Single turn is when you have a single prompt and a single response. This is usually when the AI is just getting started. It's not capable of generating stuff on its own, so you have to provide it with all the details. And another reason why single turn is used if you're dealing with a concept explanation prompt rather than a purely coding prompt. So you only need a single response, and if you can include code to help explain the concept, then that's better. Multi-turn is when you have multiple prompts and responses. So one, there are multiple steps, so each step is based on the previous. It can remember what the last one was about. So if you want to make a website, you can start off by asking the AI to make an HTML template, and then on the second prompt, you ask it to insert a input field, and then a third step, you ask it to insert a button. So it remembers all this stuff from the past, and it will add on top of the previous responses. And multi-turn is more often used for coding related stuff, not so much concepts. You want to make incremental changes. This is easier for the AI to understand. And also, usually multi-turn is done when the AI has some ability to generate responses on its own. So you would just edit the response, or the AI could give you multiple responses for you to choose the best one, and you give an explanation about why you picked one response is better than another and why you made the edits you did. So right now it sounds almost like prompt engineering is kind of like regular programming, but there are some differences. The most obvious surface level difference is that you need to explain a lot of stuff. You need to include an explanation along with a code, and doing this will help the AI learn. It also helps the end user who's gonna receive the AI response. It's because you're often trying to you're often trying to educate people who don't aren't very knowledgeable. So it's always good to explain things as much as you can. And there's two priorities in AI, in giving AI responses. Number one is that your code runs. So if your code doesn't run, then it's pretty much useless. And in order to make it run, you sometimes have to cut down on what you can do. You can't like try to use the most elaborate environment setup. Like code that runs is always better than code that doesn't run. So and you have to sometimes figure out a way to compact this the code. And I found a lot of times when I got like something like 100 200 lines of code from the sample data, and I managed to compress it down to just 10 20 lines. It's there's a lot of overcomplicated code on the internet. And in some occasions I've been the first to do stuff like in excuse me, my mic dropped. So in Java, when you were make hosting a web service, you were normally using Tomcat or using Spring Boot, which is just embedded Tomcat. But you can also use core Java to host a website. So the end result was that I had 20 lines. It could do. I had a Java core web server that could uh, handle post requests, and the internet so far does not have that kind of stuff. They always tell you to use Tomcat, which is a lot longer and a lot more setup. So there is a lot of inventive work sort of here. And modular code is better than specialized code. So this means you're often using low level or core programming over framework usage. So, like that example of using uh, Java sockets to host a Java server doing post. This is an example of modular. It's you can just make a mild edit and you can change a post to a get, and you can also get HTTP headers. Yeah, it's just a lot less setup than if you were using Tomcat. And so running code is the first priority. The second priority is verbosity, or the verbosity just means keep it as short as possible, as relevant as possible. And sometimes you might spend like an hour, 2 hours proofreading your work just so that it can be like maybe one paragraph shorter. And I think it might be it's worth making it shorter because sometimes these uh, responses are viewed by thousands of people, so it does add up. And also, it makes it easier for the AI to learn because it doesn't have to like figure out which parts of your response is relevant when your response is shorter. Right, here's a like step by step sequence of how you would work in how you would do a respond to a prompt. So first of all, you would read the instructions and determine the intent of the user. Uh, I think that some of the difference between prompt engineering and like if you're working at a regular company is that at a regular company they have they tell you to do specific things. They tell you to use like you have to use Java, you have to use a certain version of it, and you have to use, for example, Angular, and you have to use tokens. But as a prompt engineer, you only have to determine the intent of the user, and if they don't tell you to use Java or they don't tell you to do so and so, you can determine what's the best response. And and somewhat the AI it prefers like a diversity of approaches because that helps it learn. And again, you have to run the code. You have to make sure that uh, the response you're giving is actually working. So you have to run your code yourself first. You sometimes have to take a picture of it and submit it, and then you have sometimes you had to fill out a text field explaining your process of how you got there, and then on the response you would uh, add a add an explanation of why the code works properly and why the way it works the way it does. All right, metrics of a good response. Number one is helpfulness. So this is kind of a broad term, but like helpfulness means did you relevantly respond to the user? Like if the user was asking for bicycle information, did you like number one give them information on bicycles? If and number two, if you didn't give them information on bicycle, did you at least give them the stuff information that was related to bicycles? And sometimes the user like they didn't ask for stuff, but your your they didn't specifically ask for something like I don't know if they were to ride a bicycle and you were to I don't know tell them that there's going to be a thunderstorm today, then I guess that would be also helpful to the bicycle person that would want to take a stroll out today. Another thing you have to watch out for is formatting. I know it doesn't sound like a big deal, but it makes the AI look more professional if it's properly formatted. And we do get reminded constantly, like make sure you include a period, make sure you do a paragraph, because like you just get uh, they'll give you trouble if you forget something small like that. And each project has specific instructions, but uh, generally prompt and responses have to be helpful. The code needs to run, good grammar, and you need to format it. So uh, when you finished your response, there's multiple layers of checks on it. So one there's one check that you can see that you have some people who are reviewers rather than prompt engineers, or sometimes a lot of engineers are also both. So the reviewer will look at what someone else did. They would tell that other prompt engineer what they did right or what they did wrong, and if it's mostly okay, they'll just make some edits and submit it. If it's mostly not okay, then it gets sent back. After one review is done, it then goes off to the client, I guess. There's multiple. I've heard there was like 10 other reviews after that. But you don't get to see the feedback on those reviews. And companies like Google, ChatGPT, Microsoft, they don't do the prompt engineering work themselves. They often send it off to companies like Remote Task, Invisible. That's where I worked, and these companies do the prompt engineering work, and we have like these small projects. Each project has its own instructions. Right, independent components. So when you're working on a project, you think that you've improved the AI, and then you go to another project, and with similar tasks, and then you find that the AI sucks now. You might be wondering what happened. Well, there's a lot of experimentation. There's different AI components, and they're trying out different components. So maybe you started off with a mature product, and then you guys send off to another product which was still in its early phases, and these components get combined together later on to form a single AI that's presented to the user. Also, AI is not a single field. Like the AI might be good at doing Java programming, but not so good at HTML programming. And that Java programming component is combined with the HTML component into full stack programming into another component called full stack programming. So you gotta like work on all three of these components independently. And this is the end of my presentation.